Hello everyone, welcome back to STEM with Chantel.
Now we're at Lock 12 in Ravenna, Kentucky, and this is the new plant that we have going in. It should be online by the end of 2020. We're now up in the control building. Back here we have a control cabinet like we had at the other sites with the microprocessor and all the control relays. This will be controlling 5 turbine generators. Over here we've got the similar controls like we had at the other one, where we'll be able to have a screen to monitor things. And that, again, the screen will be hooked up and we'll be able to shoot the images onto the internet. So that's all over here. Over here we have our control panel for each of the turbine generators, where we can monitor the turbine generators as far as any problems that might be with them as far as vibration or oil levels or anything. And like you saw at Lock 7, we have the dissolved oxygen controller up here, just like at Lock 7. So that's very similar here. So what happens here is we'll show you where the power comes from, but once the power comes into this building, it comes into our drive room. Now, these are the drives that are very similar to what you saw at Weisenberger's. The only difference is that these drives are much larger. And these drives are for 10 times the size of Weisenberger's. Weisenberger's was 50 kilowatts. These are about 600 kilowatts. So it's 12 times the size, but it's in that general range, the size of these. So the power comes in here. Again, it's being made. This plant is the first in the United States hydroelectric plant that uses variable speed for a new power plant. So we'll be making variable speed, variable frequency power. It comes up in here into these drives. In these drives, it gets converted over from variable frequency AC to DC power, and then it gets converted with an inverter over to 60 cycle AC, which can be put into the electric grid. So the power goes up here, gets transformed into 60 cycle AC, comes out of here, and goes into our switch gear right here. This is the cabinet where we can cut off and isolate each of the units if we need to work on them. So once the power goes out of here, it goes underneath the floor, outside. This is the transformer for the plant. And this transformer is not just a transformer, but it also has the main breaker. The main breaker's in the front and the transformer's in the back. So the power comes over to here at 480 volts, and in the transformer back there, it gets bumped up from 480 volts to 12,470 volts, which is the voltage that the Jackson Energy distribution line runs at. So it goes through the transformer, and then in the front section here is the main breaker. And this is a vacuum breaker that, like at Lock 7, and it can isolate the electric grid from the plant if there's any problems. The controller for that is over in the control box, just like it was at Lock 7, a protective relay, microprocessor based. So from here, the power goes out here, goes underground to, you can see up above there, there is the electric interconnection point with Jackson Energy. So at this point, we go on to the Jackson Energy system, and the power is taken and used by Jackson Energy, sold and used by the Jackson Energy members. So the question is, how's the power get up here? We'll go downstairs and look and see. So this is the point where the cables come out from the drives you saw up there. They'll come down through these these carriers here into those trays and then down into all those conduits there. Those conduits are running down underground, down to the power plant, which is down in the lock chamber. So it's coming from up there at the drives, down and through those conduits. So let's see where it goes from here. Okay, we saw where those conduits left the building. The conduits are actually moving down through here and into the top part of the esplanade. So you can see, if you look down here, the cables, the conduits with the cables go straight down here, and underneath where you see the front of that crane, it will go out into where the powerhouse is sitting out there. The powerhouse is under construction and it's just about built up to the point where we will be putting the final pieces of conduit in. So here's where the hydraulic lines come out from way up there at the powerhouse. They end up right here. They'll take a turn and then they'll go down through these 3 sets of conduits there to take them over to the powerhouse. And then, but the main cables, which are the power cables, they continue straight down through here. And you can see right here, here are the end of those conduits that started up in the powerhouse there. Once we get this wall poured here, we will extend these conduits out where they will take the cables to each one of the turbine generators. If we come over here, we can look and see. There'll be 5 turbine generators in here that will sit down in these holes. They get lowered in there. They're submersible turbine generators. And then there will be a wall between each one of them, so each one can be isolated, so you can turn them on and off. The hydraulic system that you saw up in the control room, there'll be big gates that go up and down, that slide up and down in those slots right there, which will turn the turbine generators on and off. And then the power, so the power cables come here, they go down and they get hooked up to the turbine generators that are down in these holes. So what happens is the water will come in from upstream. That concrete wall you see there will be removed. The water will come down, come in through here, go down through the turbine generators, and then out the backside into the downstream, which in this case is 17 feet lower. And it's that differential between the upper stream and the lower stream, which you can see at the dam over there. That is where the power is made. It's that differential between the two. So down below, I was talking about the turbine generators going down in those holes you saw. These are the turbine generators. And this part of it here is the generator. And they're sitting on their sides. When they're used, they'll be standing up. And this part over here is just a cover which covers the shaft that's down in here. That shaft will go into the top of the turbine units, which are there. So when it's finished, they will be 13 feet tall and weigh 23,000 pounds each. These were built in Sweden by Flight. They are a modification of a probably the most popular submersible pump in the world. In the pump version, they make about 200,000 of these a year. Sell them around the world. This is the turbine. The top part is the gearbox, which speeds up the water. The turbine turns at about 225 RPMs. The generator is at 900 RPMs. So the turbine's in the bottom part. We'll look down in there, and if you can see down in there, we can see their stainless steel blades on a bronze hub. And those blades turn, again, they turn at 225 revolutions per minute. But, as we described a little earlier, these are variable speeds, so we will be able to slow them down from 225 to a slower speed when we need to keep them always at the most optimal speed. So this, and then again the generator sits up on top, stands up on top of that. go in as one piece and go down in those holes, and the water goes down through there. When the water comes past our trash grating at the front at about 1.5 feet per second, by the time it gets down to these blades, it's going to be going past these blades at about 24 feet per second. And then it goes back down through our draft tube and goes out the back. It gets slowed down again. But it gets going pretty fast when the water goes by here. Like at our Lock 7 plant, this plant will use about 1 million gallons of water a minute, enough to fill an Olympic-sized swimming pool. And the units together, the 5 units together, are rated at about 2.5 megawatts. That's 2,500 kilowatts. On average, these 5 units will make enough electricity on average for about 1,200 homes. All right, once the power is created and it goes through the transformer up there at the control building and it gets bumped up to the voltage of the Jackson Energy system, it gets put on these power lines here. And these connect up across the river to Jackson Energy. And so the electricity will go into Jackson Energy's Rice Station substation and will be distributed out and generally used by their customers in the Estill County area. So this will be making a lot of the power used here in Estill County, make it right here in Estill County and use it right here in Estill County. So it goes up out here across the river and hooks up into the Jackson Energy system.
Thank you for tuning in for STEM with Chantel.
Here at the Jessamine County Public Library.
Be sure to like this video, subscribe to our channel, and share this video so you can be aware of the next time we upload. Thank you.